Okay, here we are with x over x squared minus 9 minus 1 over x plus 3. My first step is to factor denominators. So I want to completely factor the denominators. This way I can find out what our common factors are. So I have x over x plus 3, x minus 3, minus 1 over x plus 3. The second fraction is going to need an x minus 3 so that it has a common denominator. So if I multiply the denominator by x minus 3, I need to multiply the numerator by x minus 3. Now I have that common denominator of x plus 3, x minus 3, and I can take the numerator of the first fraction minus all of the second numerator. And that's going to go right there. And when I say all of, I need to make sure that I have all of in parentheses. So the first numerator is x, and the second numerator is going to be 1 times the quantity x minus 3, which is just x minus 3. So I'm going to actually rewrite that 1 x minus 3, the quantity of x minus 3, all over x plus 3, x minus 3. Now we cannot start canceling things out, because if we look at the numerator without simplifying, this entire numerator is in grouping symbols. So the only thing that's going to cancel out from this numerator is if I have the same exact grouping in the denominator, and I don't have the same exact grouping in the denominator. So I have to simplify that numerator first. So we have to simplify the numerator first. So we factor the denominators, we get a common denominator. And then our third step is to either add or subtract our fractions, the way that we were taught long ago when we learned how to get those common denominators. Now, I'm going to simplify that numerator. X minus x is 0, and then this negative 3 is a positive 3. So I have a 3 in the numerator, and in the denominator I have x plus 3, x minus 3. And I'm keeping my fingers crossed that that is the correct answer. Let's make sure I did not make any mistakes. X plus 3, x minus 3, that's good. That's an x plus 3, so I'm going to multiply by x minus 3. And then I'm going to distribute that negative sign, which is your subtraction sign, so that'll be negative x and positive 3. That would be a negative x, so x minus x is 0, plus 3, there's my 3, over x plus 3, x minus 3. That works. Okay, let's try again, number 14. And if you feel pretty good about factoring, then that's probably one of the biggest challenges, is just that factoring. Now I'm going to write everything out here, factoring the denominators. So my 15 is going to stay the same. X plus 1 in the numerator stays the same, and 2 minus x stays the same. I'm going to factor the x squared plus x minus 6, and that's going to factor to x plus 3, x minus 2. Now, it would be really nice if this x minus 2 and this factor was also x minus 2. And we can make that happen by factoring out a negative and then bringing that negative to the positive or the plus sign and making it a subtraction. So I'll show you. I'm going to do each step slow. X plus 3, x minus 2. And then I'm going to have a minus, and instead of 2 minus x in the denominator, I'm going to have x minus 2. So I'm going to switch the positions of the two values, and I'm going to factor out a negative. Okay. And then in the numerator, I still have x plus 1. So my second fraction now just needs an x plus 3. So I'm going to multiply the numerator and the denominator by x plus 3. I'll get to FOIL. So I'm going to have a fraction with a common denominator of x plus 3, x minus 2. And then my first numerator is 15. And I'm going to have minus all of the second numerator, which is x squared plus 4x plus 3. I'm going to need a little bit more room here, so I'm going to cheat by resizing my work, scooting it up. And I have 15 minus x squared minus 4x minus 3. And that's going to be negative x squared minus 4x plus 12. And in order to make sure that my fraction is in its simplest form, I need to factor the numerator and look for common factors that will cancel out. So I'm going to factor out a negative. It's going to leave me x squared plus 4x minus 12. And I believe that does factor. That's going to factor to be x plus 6, x minus 2. And the denominator is still x plus 3, x minus 2. And then the x minus 2's cancel out. And I've got the opposite of x plus 6 all over x plus 3. That's our final answer. Okay, 2 more. We've got 2x, and I'm going to factor the denominator. That's going to be 4 times the quantity, x minus 4. And then I've got minus 3x. And then I want this 4 minus x to be an x minus 4. So when I switch the positions, I'm going to have to factor that negative out, and I'm going to change that subtraction sign to a positive sign. Now the second fraction just needs a 4. So I'm going to multiply the numerator and the denominator by 4. I now have a common denominator of 4 times x minus 4. The first numerator is 2x, and the second numerator is 12x. 2x plus 12x, remember you have to simplify first before you can cancel. Simplify first, and then you can cancel common factors. Now, in that 14, I have a 2 and a 7. And in the 4 in the denominator, I have 2 2's. You can think of it that way. So that's how my brain kind of sees it. I see 14 as 2 times 7, and I see 4 as 2 times 2, and then these 2's cancel out. Some of you see 14 divided by 2 is 7, and 4 divided by 2 is 2. No matter how your brain is working, you're going to end up with a 7x in the numerator and a 2 times the quantity x minus 4 in the denominator. And that's our answer. Okay, number 16. See if you can get started on this. Maybe press pause and try this on your own. I can already tell I'm writing kind of big. I'm going to have to squeeze things in here. Minus 3x plus 1. And then I'm going to have 4 plus x and 4 minus x. Okay, so if you did not pause the video, I recommend kind of looking at what I did right here and pausing it here and seeing if you can do the rest on your own. Yeah, I'm going to make some room here. Gotta love technology. Okay, if you tried it and you've pressed play and you're back, hopefully you said, okay, I need an x plus 4 and an x plus 4, because that's what the second fraction has. And the second fraction is going to need an x minus 4. So we'll have x minus 4 over x minus 4. And then the third fraction, 4 plus x, is the same thing as x plus 4. So now they all have an x plus 4. They almost all have an x minus 4. It's just that this has to change, which means I'm going to flip and then change that subtraction to an addition. So I'm going to have x plus 4, x minus 4 in the denominator. I'm going to distribute the numerator. That's going to be 3x squared plus 12x minus second fraction, x minus 4x plus 4. I'm going to distribute and get x squared minus 4x. And then I'm going to have a plus 3x plus 1 in the numerator. I'm going to have x plus 4. So I'm going to rewrite this factor as x plus 4. And I'm going to now, since I took that negative out and made the subtraction a positive, I'm going to have x minus 4 instead of 4 minus x. Oops, I'm not sure why I did that. Let me see. There we go. So now all of the denominators are the same. They all have an x minus 4 and an x plus 4, or an x plus 4, x minus 4. It doesn't matter which order we write it in. Before I start adding and subtracting, I have this subtraction sign right here, and I'm going to have to subtract all of that numerator. So I'm going to write that out so I don't miss a sign. 3x squared plus 12x, and then I'm going to subtract all of x squared minus 4x. So I'm going to have minus x squared plus 4x. And then my positive sign right here just gives me plus 3x plus 1. Now I've got 3x squared minus x squared is 2x squared. And then 12x plus 4x plus 3x is 19x. And then I have a positive 1. And then I have x minus 4 times x plus 4 in the denominator. Now, the numerator, I can tell, does not factor. The reason it doesn't factor is because that 19 in the middle is way too large. If I try and do that and say this is 1 and 1, there's no way my outer and my inner will have any combination close to 19. So the numerator doesn't factor, so we're going to leave it just like that, and that's our final answer. Now in the next video, I'm going to simplify complex fractions. So I'll define a complex fraction, and then I'll show you. We're going to need some highlighters on this one. So they look complex, but we're going to simplify them so that they're not.